So we are going to discuss about electric dipole. What is that? As a student of physics, I think you have chemistry in your syllabus also. You have studied electric dipole in chemistry. That is a combination of two equal and opposite charges separated by small distance. Minus q and plus q is there, or you take this one plus q, this one minus q, whatever. Then this combination, when you assume that distance between them is small, is known as electric dipole. Electric dipole is characterized by electric dipole moment. What is that? Electric dipole moment P equal to Q into 2L. 2L is what? This we have taken as vector. It is directed from minus Q to plus Q. Vector. Electric dipole moment directed this way. So P is a vector directed from minus Q to plus Q. Okay? So we are going to consider this diagram. Separation between them, we are taking 12 for some better calculation. You can take D also, no problem. Distance between two charges is equal to D. Dipole is characterized by dipole moment, but what will you do with this dipole moment? Electric dipole moment calculation is not so important, but electric dipole moment comes when you consider the electric field strength. Electric field strength due to this dipole, but concept will remain the same whatever we have learned before. We are going to calculate EFS due to an electric dipole. Minus Q plus Q separated by some distance D equal to 12. Okay. We'll find electric field strength in axial position. Axial position means on the axis we want to find. How to? On the axis. This is our origin. Origin stands for what? O is the midpoint of AB. Okay? The point P lies on the axis of the dipole. P's distance from O be R. This one L, this one also L. Okay? So let us find EFS at P due to plus Q and P. I am just telling you I am taking due to this point charge at A electric field EA. In what direction? EA will be directed towards. What about EB? Directed towards right. If is at P due to plus Q at B, we'll find first, that is EB. This is what? Formula you know, AQ by R square, but R is R minus L because this distance R minus L. From here distance R plus L. So electric field at P due to plus Q at B will be directed towards right. EB. AQ by R minus L whole square directed towards right. Okay. Clear? If is at P at P due to minus Q at E. This is going to be what? EA. In what direction? Directed towards left. Okay. So net electric field at P will be what? This is very simple because ideally towards right or towards left. So net field at P will be just one minus the other. Which one larger you think? EB or EA? EB. So EB larger. Therefore, net EFS at P is EB minus EA. That is AQ by R plus L whole square. Take the LCM. Just simplify it. A plus B whole square, A minus B whole square. That is 4AB. This by solid. So EB minus EA will be EB minus A will be, I want the expression P equal to 2QL. Okay? 2QL I am getting over there. K into QLR by yes, 2R will be there. So it will be K into 2R into P. If you write P vector, then it's okay. Otherwise, just put P over there. Vector I am assigning. So E equal to, what will be the direction here? That is important. If you don't say direction, then you are wrong. EB was towards right, A was towards left. So it will be EB minus EA towards right. This is towards right. So E axial. Why axial? Because of the axis, on the line segment joining them. E axial equal to, I put an arrow over there. This will be 1 by okay, 4 pi 0, and this numerator we are writing 2RP. If you mention direction towards right, don't go for vector. No need. Okay. So E axial is 2RP by 4 pi 0 R square minus L square wholes. Now, dipole I have started with by this assumption that the distance between them is small. I told, so here R is much larger than L. I am writing if, because in some calculation they say the value of L, in that case you have to remember this. If R is much larger than L, we neglect L square in compared to R square. Two RP by which one we cancel? L square. So R4 is left over there. Therefore, E axial equal to 2P by 4 pi 0 R. We check the calculation once more. Okay? Check the calculation once, whether I have done correctly or not. Okay? Hope all of you have understood. So this is directed towards right. Now one question, right? If we take the point here on the left side of A, what will be the direction? Towards left or towards right? It will remain towards right. Why? When minus q will attract, plus q will repel. Whenever you consider strength of electric field, that you do it for calculation purpose with 1 coulomb charge. Definition purpose, vanishing the small trace charge per unit. Isn't it? So here, when you take the point on the right side of B towards right, left side of A towards right. What about the point in between? Towards right or towards left? At a point in between two charges, plus Q and minus Q. Any point? No. Imagine we keep it at the midpoint. Then plus Q repelling, minus Q attracting, it will be created towards left. If the point is here, minus Q attracting, plus Q repelling, it will be created towards left. So there is a need of diagrammatic representation of this case. I am coming with that session next time. Graphically, we have to show the strength and the direction of line of force. We will find a very beautiful convention to decide it quickly. Let us go for next case here. Dipole, let us finish first. Then next we are going to do electric field strength, EFS due to dipole in equatorial position. There is another name of it. Broadside on position. EFS in equatorial position or broadside on position. Keeping minus Q first. Same convention I will, otherwise initially it will have a problem for you. Minus Q plus Q kept at A and B. We want to find EFS here at this point, A, B and C. Okay? What is the concept? Because you are calculating. No definition, please. What to do? I will keep 1 coulomb charge over there. Due to plus Q, what will happen? Field will be there directed this way. EB. Agree or not? Because we imagine the point, this point is C. We want to find strength of electric field at C. This is nothing but superposition principle. Due to plus Q we find, and then due to minus Q. Minus Q charge will be attracting 1 coulomb charge. So it will be directed towards A, away from B and towards A. The resultant field strength we need to find at the point C. This length I am keeping the same. This is our origin. This distance also I am taking from origin we have taken R. This is also R. This part is L, this is L, 2L elements, 2L. Now I think you are able to imagine what is the direction of net field at C. What is that direction? No, E and EB is just vector addition. Parallelogram law. It will be through be bisector, maybe other direction, but it will be bisector. Why? For two equal vectors, it happens. Yeah, charge magnitude same distance also. What about this distance? What about this one? Isn't it? So, E resultant. Now, why I am taking parallel? I mean anti-parallel. This is the direction of P. I have taken resultant electric field anti-parallel with P. Why? We have taken anti-parallel with P. Why? Because if I have taken this angle theta, this one theta, then this part, little bit sense of geometry, theta, this is also theta. Agree or not? In your diagram it should be there. I am assuming this one theta, this one theta. So this angle going to be, draw horizontal line to theta. That's why to field along the bisector. Resultant field along bisector. The angle between them is 2 theta and they are equal. That part I haven't told, I'll tell you now. How they are equal? How they are going to be equal? Just find EFS at C due to charge at B. What is that? Del AQ by, what is EA? AQ by, am I right? I haven't used anything new. Okay? So 2 theta is the angle. What is cos theta over there, or tan theta is what in diagram? R by L. Okay? Now, we use vector formula or component, what you like most. Component method will be fine. Okay? How? I'm just drawing. Component method we haven't done yet. No, we have done in case of church circular ring. Here we are going to apply the same thing, same procedure. This EB has two components, this way and this way. This I am writing EBY, EBX. What about this A? EAX, this one will be AY. This ink need to be changed. Is okay? EAY, EBY, EBX, isn't it? Now EB and EA have the same magnitude. So don't you think that EBY and EAY get cancelled? So I'm just starting from here. Mod EA equal to mod EB equal to KQ by EBY, what will be its value? EB sin theta. EAY, what will be the value? Tell. This is EA. So horizontal component with theta, that direction it is called horizontal, and otherwise this is vertical. EAY will be what? EA sin theta. Okay? So this is going to be what? EA sin theta plus okay. So mod EA equal to mod EB, that is KQ by R square plus L square. And we have found that this vertical component in figure EBY and EAY are equal and opposite. So they get cancelled. Isn't it? But these two, but horizontal components add up. Horizontal components add up. So net field resultant electric field strength at C will be EBX plus EAX, that is okay. EA is how much? That we have calculated. I have written the value also. Here. Here or we have the same magnitude. Let me check. Oh, this will be cos theta. Thank you. This is cos theta. Cos theta. This is also cos theta. Okay? So 2 into AQ, we have the calculation there. A and B we have calculated earlier. This is KQ by R square plus L into cos theta. Cos theta is what? L by cos theta, no? Cos theta is L by this. This is K into 2QL by K stands for what? 1 by so P by okay. So resultant electric field you got in broadside position or equatorial position, equatorial isn't it? Now again R is small or L is small. Which one? L is small. L the length of dipole axis. 2L is the length. It is small. So a 2L small, L is also very small. As or you write if better. Don't forget this. If L very smaller than R, then R square plus L square approximately equal to R square. We neglect L square. So E equatorial will be P by 4 pi 0 R cube. Okay? E axial, what we have seen? Array distance are on the axis from midpoint. So whose strength is larger? Axial. E axial is double of E equatorial. electric field in axial position is double that of equatorial position. Okay? Then at any position, you have to find EFS at any position. At any position means it is not on axial. If axial, then we got the formula. It is not on equatorial. If it is equatorial, then also you know. But if the point C is somewhere like this, from the midpoint of this, we are taking distance R, L. Then how do we account for resultant electric field at this point? C over there. How to find it? Okay. No, we will find it by vector method only. But one thing I did not tell you, this angle is known. Theta is known. Something like polar coordinate in mathematics. Okay? We have to find strength of electric field here. First you have a diagram. Due to minus Q. No, don't take this way. This will be more complicated. I am telling you one easier way to do it. What is that? This dipole moment vector directed from minus Q to plus Q. P vector directed this way. Now at the point C, due to this P vector, field will be what way? No, I forget that method. Leaving that. No, that method no. So P vector directed this way. Now let us resolve this P vector into its components. P can be directed this way. What is its magnitude? P can be directed this way. What is its magnitude? You understand what I am doing? I have not done anything new, that is just resolution of vector P. But how does it help? This P sin theta and C, you compare the position. A dipole, what you have seen? There is a dipole, along the right bisector there is a point. There is a dipole, on the axial position there is a point. If we replace P sin theta by a dipole, then what is position of C? Equatorial position. If we consider P cos theta only, then what is position of C? That is axial position. Got the point? I have shown the direction only P cos theta. It is not so much. You resolve here only at this point only. This is P cos, this is P sin. Okay? So, in figure, resolve P into its components. Number 1, P sin theta perpendicular to OC, P cos theta along OC. isn't it? Now, in this diagram only, the point C falls on axial position of P cos theta and equatorial position of E sin theta. Okay? So field that C will find by naming that as E parallel and by naming perpendicular to it as E perpendicular. E parallel what? Axial position. You remember? 2p by 4 pi 0 r cube. 2p by 4 pi 0 r cube. R cube. And E perpendicular how much? P sin theta by 4 pi 0 r. Agree or not? Why have I done this? Because of equatorial and axial position. Axial position electric field due to short dipole like this. Understood, no? So resultant electric field, how will I find? As they are not of same magnitude, I cannot take along the bisector. Isn't it? If they are same magnitude, then it will be along the bisector. So E resultant, this angle is what? 90 degrees. This is the advantage we should take. So ER equal to E parallel square, E perpendicular square. That is 2p cos theta by, I should use the yellow ink already. 2p cos theta by 4 pi 0 r cube whole square plus okay. So there will be p by 4 pi 0 r cube under root cos square plus sin square is 1, so it is 1. ER equal to this thing. Okay? Now, what will be the direction of this here? How do you find it? ER will be directed in what manner? That angle, how do you find? Go by vector. Okay? What I am going to do there? I am going to find this angle. No, don't take this on theta. This will take alpha. So in figure, the perpendicular, I will take the advantage. E perpendicular by E parallel. Because if a vector makes an angle theta with x-axis, then tan theta is what? This component perpendicular, this is parallel, E perpendicular, E parallel. You are doing it from class 11. This is yes, P sine half tan theta. Rest get cancelled. So tan alpha equal to half tan theta. That is alpha equal to tan inverse half tan theta. Clear? Understood? I hope you have understood. I have not done very fast. Okay? দুজন তিনজন হলো দেখছে কিন্তু, হ্যাঁ, এই আমার স্কুলের বাচ্চারা বলে